a cathode ray with a centrally placed cathode was used. True or false? True. A centrally placed cathode was used. So a whole lot of things we have talked about in chemistry. So let's quickly use like 1 hour for our chemistry. Then we solve questions, then we have a short break, and we'll move on to biology. The exam is here. Latest by February, you must have covered everything you need to cover. So you have to think about every method you will use to cover it. So by March, for revision. Then for April, by April, marathon class. We start from the beginning again, but in 2 weeks we cover the whole syllabus. That's how we do it, marathon class. Then by that time, you write your 200 questions and follow us. But please, one of the things you need to know is that your day of exam will come. I think one of you was already telling me that it remains like 83 days now. Yes. So if you keep counting down, what 82, 81, 80, and now 83 days that you think is so what? Honest thing is your chemistry topic itself, we are up to 70 something. Which means that if you use every day for one topic in chemistry, you will need 70 something days to cover it. Whereas that's not even possible. And that's why we are adding all this extra wahala. And that's why we need to have trying to be fast with the topics. Before you cover all the organic, cover all the inorganic, then cover all the physical chemistry. So it's a whole lot. So please, you don't have time. Thinking you have time. And funniest thing is that when your exam comes like this, go to the next year, 2027. So whatever you can do now to work so hard, please work. Keep working hard and make it once and for all. Anything you need to abandon now, abandon it. If you love playing game, you love sleeping, abandon all those things now. If you love gisting with friends, abandon it now. If you are the guy that love Korean movie, abandon it now. I would have said that if you are Wura, abandon it now. But I know what I've said. So if you like Korean movie, you are Wura, abandon it now. So please, tó bá jẹ́ pé oúnjẹ nìkan náà ló máa ń ṣe ṣáṣá, abandon it now. Who is the best cook in the girls' hostel? She's not around. Is she a science student? She did not come today. Surely. She's not feeling fine. Abi di oúnjẹ ló wà. Ìdàkejì of Sango. So please, I used to tell the students, whatever will waste your time now, please abandon it. Please. Don't just waste time. I used to tell you, this is not the time to start dicing. To start cutting pepper, cutting onions. You know, all of you know how to do it. All of you have a separate plate for all your pepper, separate plate for onion, separate plate for Maggi. Then you will dice everything. Crayfish somewhere, dry fish somewhere. Then you now start Basi, Mama Dapapo. Please, the best you can do now is to, what did I say you will do? Put your pots on the fire, pour water, wash your rice, pour your rice, take your palm oil, pour it, take your ground pepper, pour it, Take Maggi. Take your salt. Add onion. Then cover it. Then when, if you have money for Korea and time, then cover it. Then when you cook it in the morning, cook the one that you eat that morning, afternoon, evening, and next morning. Please, that is it. And immediately after your exam, you can now go and sit down, cook vegetable, cook whatever you love, enjoy yourself, play games for like 2 weeks, relax, calm all the tension again. But by that time, you will sit down and you'll be expecting like 370 in jam. But if you use all this time to cook, when everybody is expecting 370 and you are expecting 160, so please do all your best. It's not that easy, but please, it's all sacrifices. So let's quickly look at the quantum numbers. Quantum numbers. There's nothing much about the quantum numbers, but quantum numbers is just trying to tell us about the way electrons behave, the distribution of electrons, distribution, orientation, and behavior of electrons. So it's just trying to tell us more about how electrons behave, where you put an electron, where electrons are found. All those things are what the quantum numbers. So where electron is found and the shape of that place where the electron is found is what the quantum numbers talk about. So we have 4 quantum numbers. The first quantum number is called principal quantum number. Principal quantum number. So principal quantum number told us some things. It is denoted as n. And it has a value of when n is 1, 2, 3, 4, and so on. Your n can be 1. When your n is 1, that means you are talking about the K shell. Just like this. If I say 1, 2, 3, remember we call this K, L, M. So all these shells, they are described by the principal quantum number. So when I say n is 1, that means I'm talking about the K shell. When I say n is 2, that means I'm talking about L shell. When I say n is 3, I'm talking about M and N. Do you get that? But now, the question is, principal quantum number now made us to realize that you can know the maximum number of electrons you can find in a shell. So the maximum number of electrons found in a shell is given by 2n raised to power 2. This formula tells you the maximum number of electrons in a shell. So what does that mean? What is the maximum number of electrons I can find in K shell? That means when n is 1, that is K, Abi. So you now say that for K shell, n is going to be 1, Abi. So 2 raised to power n squared is the formula. That will be 2 into 1 raised to power 2, Abi. 1 raised to power 2 is 1, times 2 is 2. So the maximum number of electrons I can have in K shell is what? Is 2 electrons. Do you get that? So can you tell us the maximum number of electrons you can have in L shell? 8. That would be 2 raised to power 2. That's 4. 4 times 2. That's 8. Is that taken? So another thing you need to know as number 2. So if they ask you that which quantum number describes the electronic shells, that is the principal quantum numbers. And these are called what? Your electronic shells. Or electronic shells or energy levels. Energy levels. Are you there? Are you there? Do you understand this? So the next one is azimuthal quantum number. Number 2. Azimuthal quantum number. Is it like it? So azimuthal quantum number is denoted as L. So that's azimuthal quantum number. It is also called secondary. It is also called subsidiary. So you can hear it is denoted as L. Then it is known as secondary. So in some cases you see it as secondary. Some cases you see it as subsidiary. In some cases you see it as angular. So what does this one describe? All of these electronic shells, they are divided into orbitals. So your shells are broken down into orbitals. So azimuthal broke down shells into orbitals. So it has a value of 0, 1, 2, 3. It has a value of what? 0, 1, 2, 3. When I say L is 0, that means I'm talking about S orbital. When I say L is 1, that means I'm talking about P orbital. When I say L is 2, I'm talking about D orbital. When I say L is 3, I'm talking about F orbitals. So you can see that this is shell. These are orbitals or subshells. It is called subshells. So can we move on? Now, these orbitals, how do I determine them? Azimuthal usually depend on principal. Whatever the value of principal is, we tell what the value of azimuthal is. So L always give us 0 to n minus 1. L gives us 0 to n minus. What's L? What does L denote? Azimuthal quantum number. What does n denote? Principal quantum number. So whatever the value of n is, L will take the range. What do I mean? Let's say my n is 2. That means that will be 2 minus 1. That will be 1. Abi? That means L is going to be 0 to 1. So that will be 0, 1. Let me show you what I'm saying. Let's say n is 1. When n is 1, which shell is that one? That is K shell, Abi. So now, what will my L be? L is going to be 0 to 1 minus 1. 1 minus 1 is what? That means L is just going to be 0. So when L is 1, that is K shell. When L is 0, which orbital is that? S orbital. So you now write 1s. 1s. Let me show you something different so you will see. When n is 2, what will be the values of n? L is going to be 0 to n minus 1. And n is 2, Abi, minus 1. 2 minus 1 is what? That means that's going to be 0 to 1. Do you understand that? Now, at the end of the day, that means L is going to be 0 and 1. That's what it means. You just count 0 to 1. That's what it means. 0, 1. So when it is 0, which orbital is that? When it is 1, which orbital is that? That means this can be, this, when n is 2, which shell is that one? L shell, Abi. That means the L shell can be divided into S and P, which L shell can be 2S, 2P. You have never seen 2D before. So it is 1S, 2S, 2P. You can see the distribution as it's going. I hope you're following. Oh yeah, everybody, do for when n is 3. What would that be? Can I rub this part? Eh? This part, this part. And you don't know what you can use to blow. You could have used that to turn to a song. No, 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 no. What the camera? That's what she no, 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 no. People online might not know what is going on. They might be saying they should look for rope like that. Are you true? Oh yeah. So when n is 3, which shell is that? Eh? That's n. Is that n or m? That's m shell. Look at this now. How many electrons can be in s orbital? Just 2. Abi? That's 1s2. So here now, p can be 6. You remember you said something that the maximum number of electrons can have in L is 8. If you do that calculation, the maximum you can have in K is 2. That's just 1s2 for K. But for L, you can have 2s2, 2p6. That means the maximum is 8. So it has been divided. But let's do for this guy. That means L is going to be 0 to n minus 1. Abi? That's going to be 0 to 2. 3 minus 1 is 2. Abi? So that means the values of L is going to be 0, 1, 2. When it is 0, it is S, L, P, and D. So that means this M shell, which is 3, has been broken down into 3S, 3P, 3D. What is the maximum number of electrons in S? 2, 6, 10. Altogether. So the maximum number of electrons I can have in M shell is 18. And if you use your formula of principal quantum number, 2n raised to power 2, that's 2 into 3 raised to power 2. 3 raised to power 2 is 9. 9 times 2 is what? 18. So you can see the magic. So that's what this guy is dealing with. Please, do we understand that? I've not started arranging them in order of energy. I'm just showing you something. That M can be broken down into 3. 3S, 3P, and 3D. If you do for when N is 4, you will see what you will get. Can we move on? Then all these orbitals, you can be asked to talk about their shapes. Air body. For S orbital, what is the shape? A spherical. So that's dumbbell. Abi? Px, Py, Pz. For D orbital, what's the shape? Double dumbbell. So those your dxy. So double dumbbell. There are like 5 of them. For F orbital, complex. So they can ask you any of this. What is the shape of S orbital, P orbital, D orbital, and F orbital? S orbital is spherical, P orbital is dumbbell, D orbital is double dumbbell, and F orbital is complex. Can we move on? So let's move on to the number 3 now. That is magnetic quantum number. I haven't really found a place where I call home. I traveled the world in exactly break. When last do you have lights? I have no idea what everybody's love. But is it
It's hard to break it. It's just a call, only come. This my life is for rent, and I don't learn to price. Well, I just said nothing more than I get. There's nothing that I truly mine. Always thought that I would live by the sea. Number three, magnetic quantum number. So this is denoted as M sub L. So it's denoted as M sub L. So it gives what we call the spatial orientation. Spatial orientation, or something called orbital degeneracy. Spatial orientation or orbital degeneracy. So M sub L takes the value of minus L through 0 to plus L. That means it depends on L. Whatever the value of L is, tells you what the value of M sub L is, and tells you the number of degeneracy or the number of folds. What am I saying? Let's say the value of our L is 0. If L is 0, which subshell is that? S, Abi. So if L is 0, M sub L is supposed to be minus 0, 0, plus 0. But there's nothing like minus 0 and plus 0. So if L is 0, M sub L will also be 0. And if L sub L is 0, that is just telling us that you only have one orbital. That's one. That's why if I write 1s, I'll just have one like this. It will not be divided. Next one. If L is 1, what will be my M sub L? M sub L is going to be minus 1, 0, and plus 1. Abi? Yes. And when L is 1, which orbital is that? That's p orbital. That means your p orbital will be divided into 1, 2, 3. 1, 2, and 3. Minus 1, 0, plus 1. So which is now what we call p sub x, p sub y, and p sub z. So which means that if I write for before I could have that n is 1, L is 1, I must have had n to have been 2. Abi? You know, if n is 2, L is going to be 0 and 1. Abi? So the only time I can have L to be 1 n must have been 2. Shall you get that? So at the end, I already have 1s, which is from when L is 0. So now that L is 1, then my M sub L is minus 1, 0. So I can say 2 whatever. When L is 1, that's P Abi. Okay, I can just say 2P. From here now, it will be 2S and 2P if I'm dealing with it. If N is 1, L is going to be 0, Abi. But in this case now, if I'm treating this as N is equal to 2, then this would have been 2S. But it does not matter now. Just leave that one. So let's focus on this. This can be... Don't let me mix it up for you so that I don't start scattering it. You know, I didn't start with N. I only start with L. So I'm just picking a particular value of L. For here now, if I had said N is something, you would have known what this would be. If I had said N is something here, you would have known. But we are going to use a table to summarize it. I don't want to mix it up for you now. Because if I say that this is, which I can still say that means this is 2P. Abi? Because for L to be 1, n must have been 2. So that means I'm dealing with 2p. So, but some of you might not get what I'm saying here. That's why I said don't let me. But don't worry, just write that. You shall understand this. So this is 2px, 2py, 2pz. So meaning that when L is 1, you are going to have threefold degeneracy. So they can ask you 1, 2, 3. So that is called threefold degenerate. I will join everything together now, so we'll see. But just follow what I'm doing. So now I have threefold degeneracy. Oh, yeah, do for when L is 2. How many fold degeneracy will you have? We will join everything together soon so that it will make more sense. So when L is 2, which orbital is that? So that means D will be divided into how many folds? 5. So that means M sub L is going to be -2, -1, 0, +1, +2. So how many is that? 1, 2, 3, 4, 5. So that means it will be divided into 5. And that is called 5-fold. 1, 2, 3, 4, 5. So that's 5-fold degeneracy. So meaning that your d orbital will be divided into 5-fold degeneracy. So we have used 30 minutes. Can we move on? So the last one, when L is 3, yes, which part? You understand what I've explained before? Now this is magnetic quantum number. It's telling us how you divide these things into orbit. You know, if you are writing configuration P, we have 3. That you always say Px, Py, Pz. So all you need to know is that your M sub L, when this is the formula for M sub L, -L, 0 plus L. So whatever the value of L is, that is what we tell what M sub L will be. So you now said if L is 0, that means M sub L will also be 0. You can't have anything like -0 or +0. M sub L is supposed to be -L to 0 to +L. So now if L is 0, you can't say -0, 0 plus 0. There's nothing like -0 and +0. So in this case now, M sub L is just 0. And just 0 means just count it. How many? 1. That means you only have 1 box. Just 1 box. When L is 1, what will M sub L be? Whatever the value of L is, M sub L will be minus that value up to plus of that value. So now if L is 1, that means M sub L will be -1. You are no longer listening, no? That means M sub L will be -1, 0, and +1. So if you count that, that's 1, 2, 3. That means you already know when L is 1, that is P. That means your P will be divided into 3. That's what that is saying. Forget about this for now. Now, yeah, when L is 2, what will ML be? -2, -1, 0, +1, +2. That means D orbital will be divided into 5. And that's what we are saying. 5-fold degeneracy. And I now say when L is 3, what will M sub L be now? -3, -2, -1, 0, +1. And how many fold degeneracy is that? And when L is 3, which orbital is that? F. That means that will be divided into 7. 1, 2, 3, 4, 5, 6, 7. So your F orbital is always divided into 7-fold degeneracy. Please, do we understand? We will join everything together so it will all make sense all together. So, but let's learn it one after the other first. Is that okay now? Can we move on? So the last one, number 4, that is called the spin quantum number. Spin quantum number talks about the spinning of electrons. The spinning of electrons on their axis. The spinning of electron on their axis. In every orbital, one electron always go up and one will be down. That's what you usually see. If I want to fill electron into this orbital now, I will put one up and one down. Abi, you will never see that they will put both of them up in the same orbital. That is wrong. It has to be one up, one down. So how they spin one up, one down is what this one is talking about. So when you say up, the value of this one is represented as m sub s. So the value of m sub s is usually plus 1 over 2 when the electron is spinning up, and it is minus 1 over 2 when the electron spins down. That's just the value. That one is simple. So let's now bring all of them together in a table. Everything we have learned so far in a table on the quantum numbers. Are you ready? So now, if you didn't really get everything I've been saying clearly since morning, you should get it with this table now, and you should try to follow. "35 minutes gone." Oh yeah, I'm waiting. So we can have one at a 30 minutes break. So Wura. So I need 1 hour class then. I need 1 hour class then. 3 to 4. 4 to 5. 4 to 5. Are you true? It's what be bed. Can I rub it off now? So now, all in a table, everything I've been saying. So the first one, let's say shell. The second one, let's say the principal quantum number. Then the third one, let's say azimuthal. Then the fourth one, let's say magnetic. Then spin. Then electronic configuration. Maximum number of electrons. So let's take them one after the other. K. When I have K shell, what will be the value of N? Abi? So if N is 1, what do you think my L would be? Do you all agree? Because L always take the value of 0 to N minus 1. Abi? 0 to N minus 1. M sub L will be minus L, 0 to plus L. Do you understand that? So that means what will be the value of n? L, 0. Abi? So that means which orbital is that? S orbital. Do you agree? What if my L is 0? What will be my M sub L? How many fold is that? Do you understand that? What will be my M sub S? That one will always be plus or minus 1 over 2. Because in this place, one will spin up, one will spin down. Then that means 1s. So the configuration is just 1s. What is the maximum number of electrons I can have in that shell? Do you get what we are doing? So let's talk about the L shell. The L shell. What will be the value of n for L shell? Do you agree? What will be the value of L for this shell? 0 to 1. So the value of L will be 0, and that 0 is talking about S, and 1. You know, if I want to write, I'll write 0, 1. Abi? You know, it is 0 to n minus 1. What's n? 2. 2 minus 1, 1. That means 0 to 1. Do you get that? So you write 0, 1. When it is 0, it is S, Abi. When it is 1, it is P. Do you get that? So now, you will now do this one. When L is 0, that's why I wanted to list it this way. 0 and 1, which represents P. So when L is 0, what will ML be? How many fold? 1. When L is 1, what will ML be? Minus 1, 0, plus 1. That's how many? 3 folds. Are you getting it? So now, what will M sub S be? It's just plus or minus 1 over 2. So now, this will be 2s, 2p. What's the maximum number of electrons? Do we get these points? Oh yeah, everybody. When L is 3, oh yeah, I do for that. I mean, that's next shell, M shell. So yeah, do for 3. The same thing I've done here. Yeah, quickly do it for when it is 3. We have to be conscious of time. Are you true? Hey. Are you true? Mr. Felix will call. So yeah. So when n is 3, what will be the values of L? 0. When it is 0, that is S, Abi. 1, that is P. 2, that is D. Do you agree? It's going to be 0, 1. I'm listing them this way so that I can use them for n sub L. You can list them straight. So that means that when L is 0, what will m sub L be? Then just 1 fold, Abi. When L is 1, m sub L will be minus 1, 0, and that's how many fold? 3. When L is 2, that means do you get that? That's 5. That's 5 volts. Then this one will always be plus or minus 1/2. Then this will be then the total number of electrons will be. So you can do the last one as assignments to practice. So you can do the last one to practice. Oh yeah, let's look at the rules that guide electronic configuration. That's the last part now. So please, they are just going to ask you 40 questions in chemistry, and all these stories might not be a part. So there are a lot of stories in chemistry. And most importantly, don't joke with your inorganic chemistry. Don't joke with it at all. Do not joke with your inorganic chemistry, especially all those nitrogen and its compound, sulfur and its compound. Know them, like what about you? I don't know, God helping me. I already thought we would have finished the inorganic this week, if not for the journey and stress of work. So at least if you have that book and you practice all those questions inside and you read the materials the way it is, your inorganic and organic is okay. Just use it along with your teachers. It's okay. We have to find every ways to make it easier. Oh yeah, can I rub the board? Oh yeah, be fast. Thank you. Sorry. Can I rub the board now? So look at the rules that guide electronic configuration. So the rules that guide electronic configuration. So we are looking at 3 rules quickly. Number 1 rule. Ẹjọ́ tí ń pọ̀ jù. That's the polar exclusion principle. Number 1 rule is the polar exclusion principle. So this rule simply states that no 2 electrons can have the same set of values for the 4 quantum numbers. It states that Polar exclusion principle states that no two electrons can have the same set of values for the four quantum numbers. For the four quantum numbers. That is, no two electrons can act in an identical manner. That is, no two electrons can act in an identical manner. No two electrons can act. I said it states that no two electrons can have the same set of values. No two electrons can have the same set of values for the four quantum numbers. No two electrons can have the same set of values for the four quantum numbers. That is, no two electrons can act in an identical manner. They can't behave in an identical. What does that mean? Let's say this is 1s2, everybody. For this 1s2, there are two electrons here. So it's more like saying there's one electron, 1s1, that is spinning up, and another one, 1s2, that is spinning down. There are two electrons. So polar exclusion principle is telling us that these two electrons, they can't have the same set of values. It's not possible. No two electrons can never have the same set of values for the four quantum numbers. Even though 3 may be the same, but the center 4 cannot. Let's look at it. For this first electron, what is the value of n? 1. You know, that's when this one is there. That's 1. What is the value of n? 0. Because for you to have s, that must have been 0. What's the value of n sub n? Because it's just going to be one block. Abi? Then what's the value of n sub s? Plus half. I told you that the one that spins up is plus 1/2. The one that spins down is minus 1/2. For this one, what is n for this one? What is L? What is n sub L? What is n sub s? So you can see that these three are the same, but these are different. So, polar exclusion principle is telling us that even though 3 of them are the same, the entire 4 can never be the same. Imagine I'm comparing 1s1, just one electron, and 2s1. For this one now, my n will be 1, Abi, my L will be 0. If it's spinning up or spinning up, whatever, my m sub L is going to be 0, and my n sub s is going to be plus 1/2. But for this, my n will be 2, my L will be 0, my n sub L will also be 0, my n sub s is going to be plus 1/2. So if you look at it, are they all the same? They differ somewhere, which is here. Do you get that? That's what polar exclusion principle is stating. That no two electrons can have the same set of values for the four quantum numbers. They can never act. So they can ask you that which of the law is violated. If I give you a configuration like this, 1s2, 2s2, 2p, whatever, then I write this. And I also do this. So they can ask you that which one of them violated polar exclusion principle. The second one. Abi, two electrons cannot in the same place act the same way. It's not possible. Do you get that? One will either spin up and one will spin down. So in this place now, this is 1s2. So we are saying that we are spinning up. Number 2. So first write this. Let's define an orbital. What is an orbital in case they ask you? So what's an orbital? So let's define an orbital. Orbital is defined as the region of space. The region of space where there is maximum probability of locating an electron. Orbital is defined as a region of space where there is maximum probability of locating an electron or finding an electron. Where there is maximum probability of locating an electron, full stop. So let's move on to the next rule. Next rule is Aufbau principle. Aufbau principle. Are you ready? Aufbau principle states that in the filling of electrons into the subshells, electrons are fed into orbitals of lower energy. In the filling of electrons into subshells, electrons are fed, FED. Electrons are fed into orbitals of lower energy before orbitals of higher energy. Electrons are fed into orbitals of lower energy before orbitals of what? Higher energy. So what is that saying? When you are writing configuration notes, you go with this according to Aufbau principle. This is like your K shell. This is like your L shell. 3s, 3p, 3d. Like your M shell. 3s, 3p, 3d, and 4s, 4p, 4d, 4f. 5s, 5p, 5d. 6s, 6p. 7s. It's more than that too, but just to leave it. Now, maximum electron here is 2. So you draw your arrow like that. You also draw this one like this. Then you draw this like this. You draw this like this. Then you draw this like this. So which means when you are filling electrons, the maximum number of electrons you can have in S is 2. In P is 6. In D is 10. In F is 14. Since their orientation, degeneracy is 1, 3, 5, 7. And 2 electrons can occupy each orbital. So when you are filling electrons into this guy, you have to fill orbitals of lower energy first before orbitals of higher energy. So which means you have to fill 1s first. Then after filling 1s, then you go to 2s. So no matter the elements they give you, if you follow this, you can always write their configuration. Then after 2p, we have 3s. Then we have 3p. Then we have 4s. Then we have 3d before 4p, before 5s, and so on. So if you notice something, if you notice I asked you a question when we did our class on Wednesday, that I said which of them involves absorption of energy and emission of energy. So look at this, 4s filled before 3d, and according to Aufbau, Aufbau, it says that orbitals of lower energy must fill before orbitals of higher energy, which means that for 4s to have filled before 3d, it means 4s has what? A lower energy than 3d. Do you get that? So note, 4s has a lower energy than 3d, and that's why it has to feed first. So you have to feed its electron first. Do we get that? You will see that after 5s, you will just have 3d. That means 5s has a lower energy than 3d. That means 6s has a lower energy than 4f in filling their electrons. So the last one, Ohm's rule. Compound. When you are filling, transition metal. Yes, now you have to fill 4s before 3d. You know, it is when you get to transition metals that you even get to all this level. First 20 elements, you will stop at 4s. But in transition elements, you have to fill 4s before 3d. But when they want to lose electrons, you lose electrons from 4s first, not from 3d. All this you get to grow with. Can we move on? Number 3 is called Ohm's rule. Ohm's rule of maximum multiplicity. Ohm's rule of maximum multiplicity. So what does this rule state? So right. This states that in the filling of electrons, are you there? Yeah, I'm waiting. I'm waiting. I'm waiting. I've been waiting for you. Here inside my heart, I'm the one who wants to love you more. I'm waiting, I'm waiting. No matter how long I wait, he's gonna get back to me. So are you true? Are you true? 'Cause I'm still waiting. I'm waiting till you are done. I'll be here for you. You are done. So can we go on? That's how songs are being sung. Inspiration comes from everything. So Ohm's rule states that in the filling of electrons into degenerate orbitals, Ohm's rule states that in the filling of electrons into degenerate orbitals, degenerates, open a bracket, generation, degenerates, open a bracket, orbitals of the same energy, so to say. In the filling of electrons into degenerate orbital, where's my baby? She did not come. What's her name? Peace. She's not around. Where is Peace? She's in the hostel. Is she fine? Are you there? In the filling of electrons into degenerate orbitals, electrons are fed singly. Electrons are fed singly before pairing occurs. Electrons are fed singly before pairing occurs. That's why God gave your daddy 4 children singly. 4 children singly. Then later you will now go and be pairing up in the future. So children are fed singly into the family later before pairing occurs. When you find the bone of your bone, what if they pair wrongly? That's why there is repulsion. So when they pair wrongly, they continue to repel. They are online posts, but are like. So what this guy is saying is that when you get to P to D to F, those are the generate orbitals. You have to start sharing them singly before you start pairing. So let's say I have oxygen. The atomic number for oxygen is 6. The electronic configuration for oxygen is 1s2, 2s2, 2p2. Is 8. It's good to test you at times. So I was testing you. So that's going to be 2p4, right? So this orbital is just alone, so it can find its partner. This orbital is alone, it can find its partner. But this orbital are 3. And if you have 3 sisters in your daddy's house, you marry at different time. So let's give the father 1, 2, 3. Then he who finds a wife finds a good thing. Then this person finds a wife and will lock up. So the 4 electrons, you have to share them singly before you start pairing. Is that taken? So that's what we talked about. So the question now is that how many electrons here are not paired? So we have 2 unpaired electrons. Show you. Show pamọ́. Kí ni ẹ̀ ń sọ lẹ́gùn tẹ̀? Kí ni pípà tó yà máa sọ náà? Kò lọ fà. Ẹ ṣeun. Ẹ ṣeun. Mr. Phillips. All right, let's have it. What's that? When you want to say should keep quiet. Let's have it quiet. Me, I don't have anything I used to say. Me, I can say so like 100 times. I don't have any. So for nitrogen, nitrogen is not sweet without soap. It's not sweet. What is the electron, the atomic number for nitrogen? Abi? So you are going to have 1s2, 2s2, 2p3, right? So in this case now, how many electrons do we have here? 1, 2, 3. So this one have no unpaired. So you have 3 unpaired electrons. Is that taken? What to be for fluorine? Atomic number is 9. So determine the number of unpaired electrons. Now, what you have to do for me is that You will write the electronic configuration for the 1 to 30 elements. Some of you don't know 1 to 30 elements like that too. Skuti, Vikrumi, Fe, Koni, Uzi. Skuti van kọ́. Skuti, Vikrumi, Fe, Koni, Kuzin. The school that Vikrumi wants do not have cuisine. That's what it means. So Skuti, Vikrumi, Fe, Koni, Kuzin. So this is 21, 22, 23. So those are the first 30 elements. These are from 21 to 30. I want you to note the configuration for chromium and copper. Please note that for chromium and copper. Then I will check it or ask you in the next class. So that's all. Now, general questions. So far, so good. Based on what we have done on physics and chemistry, do you have any question? Based on what we have done so far. So I want to give you like 20 minutes break before we complete our biology. Yes. Nodal plane. You are talking, do they ask you a question on nodal plane? Somewhere is actually talking about the shape. Let me put it this way. With my later check, it's just like saying, you know, if I have this in physics, there is antinode, there is node. The plane, the axis is around here. If I can remember, Sha, maybe I will help you check again. But the axis around here is like the nodal plane. These are the maximum position where you can find the electron. But I think it's related to this. But we have to check again later and get back to you. So please, is there any question on what we have done so far? On the part of physics and on the part of chemistry. Do you have any question you came across and you could not solve? So in the absence of questions, I do. A metal ring is dropped. We have not done it. A metal ring is dropped from a certain height and passing through a uniform magnetic field. Which of the following statements is true? A metal ring is dropped from a certain height and passes through a region of uniform magnetic field. So from a height, that means there is gravitational field and there is magnetic field. So which of the following statements is true? The ring's acceleration is less than g only when it is entering or leaving the magnetic field. The ring's acceleration is greater than g when it is entering the magnetic field. The ring's acceleration is less than g when it is completely inside the magnetic field. The rings BeV equals F is equal to BeV. For gravitational field, Fg, magnetic field, please. Gravitational field is going to be, I don't want to use GMM. Okay, let's say force. What relates electric field? That is force per unit charge, Abby. So force is going to be QE, right? So here now I can say big EV, you know where I got this, is equal to QE. So the velocity, I want to relate it. Velocity is, all of this will cancel. That will be E over B. So the higher the magnetic field, the lower the speed. The higher the electric field, the higher the velocity. So, and which means that when it enters the magnetic field, then V should reduce. And if V reduces, acceleration will reduce. Yes, to this one. They are inversely proportional here. Acceleration is equal to V over T. So whatever happens to V, as you are changing acceleration, as you are changing velocity, you are decreasing. Then that will be deceleration. Check it. That's all you can relate. So as it's entering the field, then the acceleration should be lesser compared to the electric or gravitational field. Do you get that? You can also use your GMM and not. Or you can say that, let's do it this way. Something like mg is equal to BEV. V can be equal to mg over EV. So G, but I mean, what's it called? So if this one reduces, this should increase. If this increases, this should reduce. And they should be directly related. All those are jam questions. Where? But that's by the way. So, please, do we have any other question? So by 2, this is 2 o'clock. 2:16. So by, when do you want to finish your break? Do you still want to have biology today? Yeah. Should we have our break till 3? Then we have biology from 3 to 4. No biology. It does not cost me anything. I just want us to end variation so that by Monday we start adaptation. I know. You want to go? You don't want to go? No, we don't. Yes, we do. Do you want to go? Please. Oh, you have your break. Just buy what you eat from now till 2:40. So by 2:40, you come back to class. So we use 1 hour for biology, and you can go.